Okay, so you're getting ready now to start on our next lesson, but before we do, let's go back a bit and take a look at our first lesson's objectives and make sure that you're good at them. So here they are over here. You should be able to now definitely identify and name points, lines, planes, rays, and line segments. Use the symbolic notation to tell the difference. What is a point, right? Capital letters. Lines, how do you mark that it's a line? A plane. Rays, what do we do to mark that it's a ray? And a line segment. How do we tell the difference between all these things using just the symbols, right? Describing the possible intersections of lines and planes. So think about when lines meet, they meet in a point, right? And when lines meet planes, think about when I was running around yesterday with the shield and the sword. Remember how many different ways could that line intersect the plane? Okay, we talked about what the construction tools were, right? And the difference between what's a sketch, right, drawn with no tools, a drawing where you get to use the measurement tools, and a construction where you only use the compass and the straight edge. So the compass and the straight edge are the construction tools, right? These terms should all be familiar to you, okay? So remember that I had you write on the left-hand side a number over here for how comfortable you were. Take a moment and write on the right-hand side a number for how comfortable you are here. Okay. Now, make sure you're comfortable with all these terms. We're not going to go over them right now, but you need to make sure that those are things that you feel good about. And if not, now would be a good time to bring it up. Mrs. Taylor can help kind of make sure you understand each of those terms. Okay, now we're getting into translating and constructing line segments. So we will not have in this video all of this here because some of this I'm going to want to do with you in person. So we're going to focus on the things that are over here, learning goals, your key terms, and your constructions. So now you're going to pause this video for me, and when you do, everybody's going to read through these objectives and then evaluate. How well do you know these things, right? Can you do these things? And then over here, highlight your key terms. Find the 3 to 5 key words for each term, right? Check out what constructions you're going to be working on, all right? And look those over. So go ahead and pause the video now and make sure you do those things. Okay. All right. Now we're getting ready to get going in here. We have this thing, Don, Frida, and Bert. We call them D, F, and B. All right, they live in a town. The streets are all laid out in a grid system. Don lives 3 blocks east of Descartes Avenue, 5 blocks north of Elm Street. So just looking here, here's Elm Street, and there's north. So if he's 5 blocks north, you're going up 5 blocks. And this is Descartes Avenue, which, by the way, Descartes, that's a funny, it looks like Descartes, right? That's a funny French name, but that's the guy who made up this coordinate system, the coordinate plane. That was the name of that mathematician, René Descartes. Anyway, so he lives how many blocks over? He lives 3 blocks east. East is this direction from Descartes. So 3 blocks east, 5 blocks north, right? So Don would be, what, 3 blocks east, 5 blocks north. That's where Don is, right? And then it says Frida is 7 blocks east and 2 blocks north. And then we have those 2 locations. So here we go. 3 blocks east, 5 blocks north, 3, 5, and 7, 2. So I'm going to mark those here so I don't forget them. So Don is at 3 blocks east and 5 blocks north. Frida is at 7 blocks east and 2 blocks north. I hope I got that right. If not, you're going to go ahead and fix that for me. So we'll go over 3 blocks east and 5 blocks north, and there's Don. I mark it with a D, right? And then Frida is 7 blocks east, 2 blocks north. There's Frida. Okay? And what we're going to end up with is 2 points separated by a distance in the plane. And then what we'd want to know is it says label each location, so we labeled each location, the coordinates of the point, I've got them written down over here, and the letters. And what we're going to get into is there is a distance that separates these points. We're going to try to figure out what that distance is, okay? And I'm not going to scroll forward, but I'm going to just show you this, okay? For any time you have a distance in the coordinate plane, anytime, you can always, so you have 2 points and you have a distance that you want to measure. So what you do is you start at the first point and you draw a vertical line down, right? And then you go to you make a turn there, right, in the direction towards the other point. And what we end up with here is, what kind of triangle is this? We end up with a right triangle. This is a right triangle, 90-degree triangle. And if you got a right triangle, I find a lot of kids were taught, a squared plus b squared equals c squared, right? I don't really like that. That's kind of, I don't know. I guess in junior high they use that term a lot. Some teachers like to use that. But it's not really, it can be confusing. What is the A, what is the B, and what is the C? And the proper way to call this is to call it a leg. I'm going to use this cursive L. That's the L that we write in cursive, plus L again, which is another leg squared, equals the hypotenuse squared, right? The hypotenuse squared. This is Pythagorean Theorem, right? And what you have to do in order to do this is you've got to be able to recognize first, where is the hypotenuse? The hypotenuse is always directly across from the right angle. So if this is the right angle here, then this distance that we don't know, that is the hypotenuse. So in other words, another word we can use for the hypotenuse, for h, we can say that the hypotenuse is the missing distance. That is equal to the distance, right? All right, distance. And so if I was going to solve this using algebra, what I would do is, since this side of the equation is squared, and I want to know what h is, I would take the square root of this side, and then that way the square root of a square, well, they'll cancel each other out. And then I'll take the square root of this side. So basically it's telling me the distance between these 2 points is equal to, figure out the square root of whatever this leg is and whatever this leg is, and then we just plug them in. These are the legs over here, right? So let me mark those over here, a little different color. There's L over here, and there's the other L over here, the 2 legs next to the right angles. So, this is just an easy count, right? So I can just go down 1, 2, 3. This is 3. That leg measures 3, and this leg measures 1, 2, 3, 4. So we have 3 and 4 for the legs. So I could plug those in here now, and I could say the square root of 3 squared plus the square plus 4 squared, that's going to be equal to the distance. I'm going to write D for distance. So this right here, I didn't know any of this stuff before. I just knew the 2 points, right? I just knew D and F. And then I wanted to find the distance between them, and I made this right triangle. See, I just drew it out. Okay? Now, how did I know this was 3? What did I do to measure this as 3? So you might have remembered right now, I just counted. I just counted the blocks. But mathematicians, we don't like that. That's like only works for really small numbers. It's really bad to try and count if you have a big number. Imagine if this was, a distance and we were measuring this and it was, 7,139. Well, I wouldn't want to count. So one way that we can find a distance when we don't want to count is through subtraction, right? The distance, like on a ruler, is just really the difference between here and here. Okay? The difference. And there's a Greek letter which we'll use in the future. It looks like a little triangle, right? It's a little triangle. And that word is called delta. Delta refers to, how, just like a delta, a river delta. You ever seen a river that comes down and when it gets close to the ocean, it spreads out and they have this thing they call the alluvial fan. And anyway, it kind of makes this little shape like this, almost like a Y, the river. As it gets close to, here's the ocean, it spreads out. And it refers to the change, because up here the water comes in fresh, right? This is fresh water. When it gets down here to the ocean, it turns into salty water. So it's a change here. So this symbol, the Greeks called it delta, right? And it means change, the change between. And so here I'm looking at the change between 5 and 2. So this is what we would call delta. This is the y-axis. So I would say delta y. That's how long this leg is, right? It is the change in the y-axis. And we find delta by subtraction, right? So it'd be 5 minus 2. 5 minus 2. When I subtract those, I get from 5, take away 2, and that tells me, oh, it's 3. It's 3 long. That's delta y. Over here, I have another one, right? And this one, again, I counted to figure out that it was 4. But I could also do, figure out this distance by talking about delta x, right? What is the change in the x values over here? Well, this would be 7, take away 3. 7 minus 3, right? 7 minus 3. So 7 minus 3 tells me, oh, that's 4, right? So when we look at this formula here, we say, okay, well, think about this right triangle that we formed, right? And then call this leg 1 and leg 2, and that one the hypotenuse. When we just want to talk about, to make things a little bit simpler, what we can do is we can just say, okay, we know we have these 2 points, right? And then we know we can make a right triangle. And so the first leg over here, we can call that, I don't know, we call this one the first leg. We can do that. And that's equal to delta x, right? The change in x, right? Or x minus x, right? And this second leg over here, so this is leg 1, right? And then you have leg, this is a little one I'm trying to draw in this, what we call the subscript down below, right? Down here beneath, like a submarine, it's down beneath. So leg 2, so I'm just showing the difference between one leg and another leg by using these little numbers, 1 and 2. So leg 2 is delta y, right? So I could write this out, just like this formula is here. I could write it out, and I would just call this delta x squared plus delta y squared equals the distance, right? Squared. So let's do that. Let's get a kind of a different color here. Let's see. Maybe I'll go with this thing. So I could say, just like we know this is a right triangle, instead of calling this leg squared plus leg squared equals hypotenuse squared, I could say delta x squared, because that's one leg, right? So here I have delta x, whatever that changes in x, plus delta y squared, right? So delta y, and I put that together because I'm not squaring y. I'm finding the change or the difference between x's and y's and then squaring that. Anyway, that's equal to the distance, right? The distance squared, right? And then if you think about that, so now we're saying, okay, from this point to that point, we just got to find the differences in the x's, and the differences in the y's will give me the distance squared. And so we get our final version here, right? I'm going to change this a bit. I'll use a bright green color. I hope that you guys can see this okay. But I'm going to call this, I'm going to square root both sides again. I'll say the square root of, and again, instead of delta x, now I'm going to go x minus x. So 1x minus the other x, right? A lot of times they'll go x2 minus x1. That just says find the difference between, by subtraction, subtract these numbers here, right? That'll give you the delta x, which is how long that leg is, right? And square it, and then add to it delta y, where delta y is, take one y and subtract the other, right? So y minus y, right? And again, in the books, a lot of times they make a big deal about which one is x1, x2, y1, y2, right? So, and we square that, and all of that's in the square root sign, and we say that is equal to the distance. That's equal to the distance. And this right here is your distance formula. Okay? Square root of x minus x squared plus square root, in parentheses, y minus y squared. So square root of delta x squared plus delta y squared, right? X minus x plus y minus y. So how did that work right here? Again, well, we would subtract the x's, right? So here's my x's, 1 and 2. So I would say, okay, I'm going to go 3 minus 7, right? There's one leg, 3 minus 7 delta x, or x minus x, plus, right? And then the y's are right here, 5 minus 2. So I'd open my parentheses up and go 5 minus 2, close the parentheses and square it. And then if I take the square root of all of that, it's going to be equal to the distance. By the way, this is a parentheses here. I did a really lousy job of drawing it. But and this is a square sign, right? That's a 2 up there. It's equal to the distance formula, or distance. This would be us plugging those numbers, 3 and 7 go in for the x's, 5 and 2 go in for the y's, and then we have the distance formula, okay? And that actually, look, 3 minus 7, well, that's negative 4, but when I square it, I'm going to get 16, right? Because negative 4 times negative 4 becomes positive 16. And 5 minus 2, well, that's 3, and when I square that, that becomes 9. So this becomes 16, and that becomes 9. Just like we had here, 16 and 9, right? And over here we had 9, 3 squared is 9, and over here is 16. And I add those together, I get 25, and the square root of 25 is 5. And that is the answer for how far apart these two live if you went on a straight line between, who is this, Don and Frida, right? Between those guys. Okay, huge mess there. But I'm going to have this video stop here. I'm going to ask you guys to practice using this distance formula a little bit. And then you should be able to just practice this for a while. Use the calculator. I'm going to ask Mrs. Taylor, go ahead and help them if you can. Get this all practiced out. And that should be enough for today probably. But if not, I should definitely be back by now, so you should be good. Okay? That's where we're going to end this video, is you guys now practicing with a couple different points. If I give you 2 coordinates, right, x and y, and then you can use this and plug it into this formula for the distance formula, and let's have you guys practice that.